Hello guys, today I'm going to show you how to use the MultiDriven node and also how to add the delay effector and constraint on the driver node system. Okay, here we have a setup for this video. I have a cone and an armature object with 5 bones. The goal is to move the cone along the x-axis and move the bones up. Alright, let's create the driver using the LK node system. We add the first node, which is the driver source node. Since the driver object will move on x-axis, we set that to move, then add the cone. Then, as usual, we need a parameter node. Let's add that. Let me align then, get it right there, yeah? Okay, make sure it's on distance mode and then input distance and output distance. For now, let's just add 20/20. Okay, now connect it to the parameter node. Then we need to add the improved MultiDriven node. It's way better now and handles bones and an armature very well. I'll set it right there, then we see what to do. Okay, there's actually presets here that are good to have, like this 3 move one actually creates 3 entries, each with its set of axis, direction, and mode. But let's create one unified entry here to control all bones at once. Since we don't need individual movement or axis in this example. As you can see here, it creates a unified control. So the only thing left to do is add all the bones in the entries, target A, target B, like that. Now I'll add the armature and bone 1, 2, 3, and 4, but I'll not add the 5th one, just to isolate and see if it's affected to make sure the setup works. Now I'm increasing the number of targets to 4, so I can add the bones. Okay, done. So let's connect the nodes, activate node at the end. Now let's add the activate node and connect it after the MultiDriven node. Nice! When you activate, you will see the real-time viewport guides. For now, the drivers are pointing the wrong direction. That's because you need to specify which space the objects use. Let's give driver object any space for now. And for the bones, I'll use the local space at y-axis. To simplify things, just use the visual guides to make things easier. That's why LK Driver Master is unique. The visual guides really help narrow down the process of making drivers. Cool, right? Okay, now let's adjust the input and output distances. Remember, the input distance is for the driver side, and the output distance is what's affecting the driven, in this case, the bones in the armature. As you can see here, the bone's travel distance is 5 meters, and the bone number 5 that we ignored earlier is not affected, so it's working as should. Let's reduce the driver travel distance here to something small as well. Now we can test the driver by activating to see if it works. Oops, it doesn't work, right? Earlier we set the driver object, the cone, to world space Z. Let's change it to local space to see if it works. Now it works. That's great. It's working because we are moving on local Z of the driver object, since we are using the local spaces. Okay, great. You can also reduce the travel distance of the driver object as you wish, so that use less distance to still move the bones. Okay, now let's add a delay effector to control individual delay timings for the bones. The effector has the different types in the dropdown, but today we will focus on the delay effector. It supports multiple bones in this new version, so it's very powerful. It will affect the driven, obviously, and the axes you can set any, but our bones move one direction anyway, so it doesn't really matter here. We can set the delay later because we do have multiple bones here. Then connect it to the MultiDriven node below. There we go. As you can see, the effector automatically detected it's connected to the MultiDriven node with armature, then dynamically presented the properties needed. So the targets represent the bone entries in the MultiDriven nodes. So you get the idea here. Here we want to delay the bones individually. We set the delay mode to individual. Global mode delays the bones collectively by propagating the flow. Let me show you the global collective mode in action. Do you see how the flow works? Cool, right? Based on the value delay of 0.25, it distributes the delay across one by one. That's nice. Remember, it's only working on all bones because the target is set to all targets. You can also just choose one target to delay. Okay, now let's switch to the individual delay mode. We have the delays for all the bones, and they're labeled according to the bone names. Let's randomize the delays, and influence is at global, so 100% influence delays. Bone 3 is at delay value 0, so it should start first, then bone 1. Okay, let's activate. Okay, moving the driver, yeah, it's working exactly as it should. We can randomize, or let's say in sequence order, and see how it does it. Amazing. There you go. It's really fun and easy to do this and see it work in the viewport with the visual guides. Nice, that's cool. So now let's add a constraint to limit the bone travel distances. This can be used to limit facial bone controls going off limits when creating custom rigs. This is the constraint node. So yeah, if you see here, we now have the shape key support for constraints too. Use that when you're working on shape keys. All right then, connect to the same MultiDriven node, targets to all, limit type to location. I'll talk about the rest in another video. And also just leave it to that value of 1. Yeah, this will limit it at a shorter distance, so we expect a quick clip limit. Let's activate and see the result. Exactly as expected, clips at value of 1 in all the bones. Notice how we still have the effector influence together with the constraint on top. That's amazing. Since the bones are moving along y-axis on local space, let's set the limit to a value of 4 meters. Then we activate and wow, the limit changes. There, we lowered the limit again and reactivate driver and it just works. Just like Jensen. Okay, now we have created the full driver that we can use in our rigs and projects. We started with the driver source here to move the cone. I see the scene is set to world orientation actually. If you change it to local, it will show the Z blue color. Then we adjusted the input and output distances on the parameter node. Then we created the MultiDriven node and added the bones accordingly. Later on, we introduced the effectors, the delay effector specifically, then added the constraint. There you go. So thank you guys for watching this extra in-depth video of using the LK driver node system. Stay tuned for more videos like these. Please watch other tutorials on this channel, and don't forget to download the LK Driver Master on Superhive Marketplace. Ciao!